So here we have a plus-sized polynomial, and we're asked to write it out in factored form. If the biggest exponent was just x squared, we could use some easy factoring tricks, or the quadratic formula, to figure it out. However, this polynomial goes all the way up to x to the fourth, so we're going to have to use synthetic division and some smart guessing to break it down. The first thing we're going to do is guess one of the roots, which are also called the zeros, because they make the function equal to 0. To find these, we should use the rational root theorem to figure out which ones are possible. However, this gives us a dumb amount of possibilities, such as plus or minus 1/2, 1, 3/2, 2, 3, 4, 6, and 12. Instead, we're going to take a shortcut and just check the easy roots first, and use polynomial division to suss out the bigger ones. For any polynomial you're trying to factor, check to see if +1 or -1 are a root first. To do this, just plug in for x and see if the function goes to 0. In this case, I trust my math aura, and I'm going to pick x equals -1, which does indeed make the function equal to 0. Now that we know -1 is a root, we can write this as a factor, x minus the root, which we know must be multiplied by a slightly smaller polynomial to equal our original big polynomial. But how do we find out what the smaller polynomial is? Well, to do this, we can use basic algebra and just divide both sides by the factor we found. Now, to divide the big polynomial by the factor, you have a couple of options. Since my generation is full of microplastics, I'm going to use synthetic division. Doing so gives us our answer, 2x cubed minus 15x squared plus 16x plus 12. Now we go to work on the smaller polynomial we just found out. Again, we're going to need to guess a root, which we can see plus or minus 1 doesn't work this time. So we're going to move up to checking the next biggest root, +2, which we see does make the smaller polynomial equal to 0. Pro tip, if the last coefficient isn't even, then you got asked a shitty question on your test, because now 2 won't work, and you're going to have to use the rational root theorem to test even weirder roots. Anyways, since our teacher didn't wake up and choose violence this morning, 2 works as a root. So now we know x minus 2 is a factor, and we can now use synthetic division again to divide both sides by x minus 2 to find our even smaller polynomial. After letting the math do a little mathing, this ends up being 2x squared minus 11x minus 6. At this point, we have a nice quadratic that is a lot easier to factor. I like to tackle these by splitting the middle term into -12x and +1x, and then doing grouping, which gives us 2x plus 1 times x minus 6. The other way would be to use the quadratic equation to find the zeros, 6 and -1/2. However, you need to be careful when doing this and not forget the additional ×2 multiplier when writing out -1/2 as a factor. Now that we've factored all the way down, we put all the pieces back together to get our final answer, x plus 1 times x minus 2 times 2x plus 1 times x minus 6. And there you have it. That's how to factor big polynomials.
Nice!